Today's lesson is about inverse function and its derivative. So we know that graph of f inverse is the reflection of f with respect to y equals x. So if this dotted line is y equals x and this is f of x, y equals f of x. The inverse function would be the reflection with respect to y equals x. So this is the graph of y equals f inverse of x approximately. So the most important thing that I want you to recognize is that if point A and B lies on the graph of f, point with the coordinates of B and A lies on the graph of f inverse. So it means f inverse can be made by switching x and y on the graph of the original function. This helps us to get the equation of inverse function. For example, let's say if y equals f of x equals 2 square root of x minus 1 plus 3. How am I supposed to get the inverse function? We just discussed that. We can switch x and y. So therefore, I'll switch x and y, and I'll get x equals 2 square root of y minus 1 plus 3. Now we need to isolate y. So I'm going to take 3 over and divide by 2 to get square root of y minus 1. And I'm going to square both sides. It's going to be x minus 3 squared over 4 equals y minus 1. And finally, y equals 1 plus x minus 3 squared over 4. So this one obviously is f inverse of x. I'm going to give you another quick example. If f of x equals x cubed, I'm going to find the equation of inverse function. Let's switch x and y. So x becomes y cubed, and then y obviously becomes the cube root of x. Therefore, if f of x equals x cubed, f inverse of x equals cube root of x. So now I'm going to find out what is the composite function of f and f inverse. Let's say what is f o f inverse of x, which means f of f inverse of x, which means we need to insert f inverse into x. So therefore it's going to be cube root of x to the power of 3, which is obviously x. Now I'm going to switch f and f inverse order, and I'm going to find out what is f inverse o f of x. By definition, it's going to be f inverse of f of x, which means we need to insert f into f inverse, so which is cube root of x cubed, which is x. So what we got is that f o f inverse of x is x, and f inverse o f of x is also x. Even though this is an example, but it is proven that for every invertible function, these equations are correct, so it's not limited to this function. So we need that to take the derivative of inverse function. Now let's set g equals f inverse. The reason why is that when you want to take the derivative of inverse function, writing f inverse prime, there is nothing wrong with that, but it's like a little bit confusing for students. This is why we assume that we actually rename f inverse as g of x, and we'll work with g of x, which is easier to handle. Okay, so we just had f inverse of f of x equals x. Since f inverse is g of x, I can rewrite it as g of f of x equals x. Now I'm going to take the derivative of both sides, and as you probably remember, the last lesson was about the derivative of composite function. And we know that first we need to take the derivative of inside function. So it's going to be f prime x g prime f of x equals 1, because the derivative of x is 1. Therefore, g prime of f of x, which is y actually, equals 1 over f prime x. This is known as the formula of derivative of inverse function. Now I'm going to give you an example to see how it works. So just letting you know that x and y lies on the graph of y equals f of x. So if f of x equals x cubed plus x, we are going to find g prime at 2. So g also, we know that it is inverse function. So I'm going to copy the formula here again. So it says g prime at y equals 1 over f prime at x. Now we are looking for g prime at 2. By comparing these two, we realize that this 2 is not x. Actually, it is x for inverse, which is y for the original function. This is why we need to find x. This x, which is associated to y. So now, how am I supposed to do that? As I mentioned, 2 is y value. So in the original function, I set f of x, which is the same as y, as 2 equals x cubed plus x. So we never solve like the equations in like derivative of inverse function. We just test numbers. And always questions in AP are designed to be tested easily, and you do not need to solve an equation unless this is in calculator part that you can use your calculator to solve the equation. So by testing, it's obvious that x has to be 1 because 1 plus 1 is 2, right? So x equals 1. So now I can complete the formula. So g prime at 2 equals 1 over f prime at x, which is 1. I just found it. It is a wonderful formula because, you know, finding the inverse of this function is painful. But this formula allows us to take the derivative of inverse function without having the inverse function. And just we have the original function. Okay, all I need now is this one, which is f prime at 1. But taking the derivative of original function is pretty simple. So the derivative would be 3x squared plus 1. Now f prime at 1 equals 4. So put it back here. It's going to be 1 over 4. This is the derivative of inverse function at 2. I'm going to give you the last example. So given that f of x equals x plus square root of x, we are interested to get g prime at 6, knowing that g is inverse function. So as we discussed, 6, we are looking for g prime at 6, and 6 is the y value, not the x, and we need to find the correspondent x. So 6 equals x plus square root of x. Again, we need to test numbers, and obviously the number that you are testing here should be a perfect square, because square root of 3 cannot, end up being 6. So therefore, the first perfect square is 1. 1 doesn't work because 1 plus square root of 1 is 2, but 4 works. 4 plus square root of 4 is 6, so therefore x equals 4. So finally, g prime at 6 equals, according to the formula, 1 over f prime at 4. Now we shall take the derivative of f of x, which is 1 plus 1 over 2 square root of x. F prime at 4 equals 1 plus 1/4, which is 5 over 4. Put it back here. It's going to be 1 over 5 over 4, which is 4 over 5.